Li-Fi, or light fidelity, invented by German physicist and Professor Harald Haas, is a wireless technology that makes use of visible light in place of radio waves to transmit data at terabits per second speeds, more than 100 times the speed of Wi-Fi.
Li-Fi, or light fidelity, invented by German physicist and Professor Harald Haas, is a wireless technology that makes use of visible light in place of radio waves to transmit data. Though it was discovered in the last decade, proofs of concept to test commercial utilization started emerging only in 2015. How does it work? Li-Fi is a visible light communications VLC system. This means that it accommodates a photo detector to receive light signals and a signal processing element to convert the data into streamable content. Unlike Wi-Fi, which uses radio waves, Li-Fi runs on visible light. Unlike Wi-Fi, which uses radio waves, Li-Fi runs on visible light. Here, data is fed into an LED light bulb with signal processing technology. It then sends data, embedded in its beam, at rapid speeds to the photodetector photodiode. The tiny changes in the rapid dimming of LED bulbs is then converted by the receiver into electrical signal. The signal is then converted back into a binary data stream that the user would recognize as web, video and audio applications that run on internet-enabled devices. An LED light bulb is a semiconductor light source, meaning that the constant current of electricity supplied to an LED light bulb can be dipped and dimmed, up and down at extremely high speeds, without being visible to the human eye. Advantages. Li-Fi could make a huge impact on the Internet of Things too, with data transferred at much higher levels with even more devices able to connect to one another. Li-Fi offers great promise to overcome the existing limitations of Wi-Fi by providing for data-heavy communication in short ranges. Due to its shorter range, Li-Fi is more secure than Wi-Fi. Since it does not pollute, it can be called a green technology for device-to-device communication in the Internet of Things (IoT). Li-Fi systems consume less power. Limitations of Li-Fi. As visual light can't pass through opaque objects and needs line of sight for communication, its range will remain very restricted to start with. In order to enjoy full connectivity, more capable LED bulbs will need to be placed at various places. Li-Fi requires the light bulb is on at all times to provide connectivity, meaning that the lights will need to be on during the day. Li-Fi is likely to face interference from external light sources, such as sunlight and bulbs, and obstructions in the path of transmission, and hence may cause interruptions in communication. Also, initially, there will be high installation costs of visual light communication systems as an add-on to lighting systems. Challenges. The main challenge is to create a Li-Fi ecosystem, which will need the conversion of existing smartphones into Li-Fi-enabled ones by the use of a converter adapter. Also, an integrated chip that has both light-to-electrical conversion and data processing capability, Wi-Fi, Bluetooth, combined into one needs to be developed and manufactured in the millions. Potential applications. Li-Fi can be used in street and traffic lights. Traffic lights can communicate to the vehicles and with each other. Through the use of Li-Fi, traffic control can be made intelligent and real-time adaptable. And each traffic and street light post can be converted into access points to convert roadsides into wireless hotspots. Vehicles having LED-based headlights and tail lamps can communicate with each other and prevent accidents by exchanging information. Visible light being safer, they can also be used in places where radio waves can't be used, such as petrochemical and nuclear plants and hospitals. They can also be used in aircraft, where most of the control communication is performed through radio waves. Li-Fi can also easily work underwater, where Wi-Fi fails completely, thereby throwing open endless opportunities for military and navigational operations. Also, it presents another unique possibility, transmitting power wirelessly, wherein the smartphone will not only receive data through Li-Fi, but will also receive power to charge itself. Challenges and opportunity in India. The lack of ubiquitous broadband access, which thereby restricts data access, and chaotic traffic management leading to traffic jams and pollution are just two of the many problems in India. Li-Fi has scope to help with both. By converting traffic lights into LED-based access points, traffic management can be made intelligent, adaptive and real-time, and so, more efficient and effective. In the same way, street lights can also be converted into Li-Fi access points, making them broadband access transmitters to mobile Li-Fi-enabled smartphones, converting areas into seamless hotspots. Conclusion. If Li-Fi can be put into practical use, every LED lamp, indoor as well as outdoor, can be converted into something like a hotspot to transmit data to every mobile device to achieve universal broadband communication.